All right, everyone, we're just going to solve this rational equation. So first thing you gotta do is find the least common denominator, and in our denominators we have x and 3. So we're not gonna write two x's because we're finding the least common denominator. So that's going to be 3x. So I'm gonna come down here and rewrite the problem so we can cancel out some stuff. Equals 1 over x. So now what we're going to do to get a common denominator is times everything by this LCD. So we're going to come up here, times this by 3x, times this by 3x, times this by 3x. Now I like to write them up there so I can cross them out as I go. So this fraction already has an x in it, so that's going to cancel out with this x, leaving us with just 5 times 3 on the top is 15. Now we're just going to drop that minus sign down. Now this problem already has a 3 in the bottom, so those are going to cancel and leave us with 1 times x, which is just x. Drop the equal sign down. This problem again shares an x, top and bottom, so that just leaves us with 1 times 3, which is 3. Now, next thing is we want to get x by itself. So I'm going to minus 15 over, and that's going to leave us with negative x equals negative 12. Now, x can't be negative, so we're just going to divide by negative 1 here, essentially. And that's going to give us x equals positive 12. Now, quickly, just to be sure, we want to throw this back into the original and check it. So it's going to be 5 over 12 minus 1/3 equals 1 over 12. Now, we need this 1/3 to have a common denominator, which is 12, because both of these two fractions already have that. So what can we times 1/3 by to get to 12? And that's going to be 4. So times it to the top, you got to times it to the bottom as well. So we're going to have 5, 12, it's just copying that down, minus 4 times 1 is 4, 4 times 3 is 12, equals, let's see, 5 minus 4 is 1, keep the denominator, boom, 112 works, it equals 112 like it was supposed to, so that's great. Our answer of x equals 12 checks out. All right, moving over to this one. This is one where we're just going to factor the equation. So first thing is we want to make sure that a is by itself. There's no constant out in front of it, which there's not, so that's perfect. So we are just going to see what two numbers, when times together, get 10, but when added together, get 11. So how I like to do this is take 10 and write out the factors. We have 1 and 10 and 2 and 5. So let's see, if we times together 2 and 5, we're going to get 10, but if we add together 2 and 5, we only get 7. And both plus signs are here, so we know they both numbers have to be positive. So times 1 and 10 together, we get 10, and add them together, and we get 11. So we know that works, so we're going to drop those down here. Now, because the zero product property, we can just set these equal to 0, like so. Now we're just going to get x alone, minus 1 from both sides, x equals negative 1, minus 10 from both sides, x equals negative 10. Perfect. So now we're just going to throw these back in and make sure that they work. So x squared, which we're going to use this one first, so negative 1 squared plus 11 times negative 1 plus 10. So negative 1 times negative 1 is positive 1. 11 times negative 1 is negative 11. And then the 10 is just there, so we just drop that down. So I like to put these two numbers together because they're both positive. So that's going to be 11 minus 11 equals 0. And that's what our equation up here in the end should equal. So negative 1 checks out. Now, this one, x equals negative 10. So we're just going to plug that in to our original equation. So negative 10 squared plus 11 times negative 10 plus 10. So 10 times 10, negative 10 times negative 10 is 100. And then 11 times negative 10 is negative 110. And then plus 10 here. Like before, I like to add these two together because they're both positive. So that's going to be 110 minus 110 equals 0. And like before, that's what our equation was set to equal. So we know that x equals negative 10 also checks out, as well as this one.